All right, we're picking up in Chapter 1, Section 7. We're rewriting equations and formulas for any variable. So, common formulas that you might encounter that you may need to use one way or another depending upon which thing they give you. Things like temperature, okay, degrees Fahrenheit, degrees Celsius, F for Fahrenheit, C for Celsius. So Celsius equals 5/9 times Fahrenheit minus 32. And then we can actually change that up and reverse it. If they give us Celsius, we can figure out what Fahrenheit is. Simple interest. I is interest, the big I. Big P is principal. R is the annual interest rate, R for rate. And T is time in years. I equals PRT. I pert is simple interest. And distance, D for distance travel, R for your rate or your speed, T for time, distance equals RT. So, rewriting the formula for temperature. Solve the temperature formula for F. So if we go back over the temperature formula, C equals 5/9 times F minus 32. Not what I meant to do. There we go. C equals 5/9 times F minus 32. Well, we start on the outside most and work our way into the F. The F is what we're trying to set free, so we're going to move outside in. So we're going to get rid of the 5/9. To get rid of a fraction, you multiply by the reciprocal. So we'll do that on this side, 9/5. So we get 9/5 C equals the 9 on top and the 9 on bottom reduces to 1. The 5 on top and the 5 on bottom reduces to 1, leaves us with F minus 32. Then we add 32 to both sides. To get rid of the 32 on the right, you gotta do the opposite, add. If you do it to the right, you gotta do it to the left. So F equals 9/5 C plus 32. Using the formula for temperature, which has a greater surface temperature, Mercury or Venus? Well, they give us a temperature here in Celsius and they give us a temperature here in Fahrenheit. We need to change them to the same thing. We just got the temperature for Fahrenheit, so let's plug in the C for Celsius. So let's say F equals 9/5 times 427 Celsius plus 32. Bring up a calculator here. So let's see. Maybe 9/5 times 427. And that's so F equals 768 and 3/5 plus 32. So it's 800 and 3/5, which would be 0.6, because 3/5 goes to 6/10, and that's a tenth spot, degrees Fahrenheit. So Mercury is 800.6 degrees Fahrenheit. Venus is 864 degrees Fahrenheit. So we're going to go with Venus. 64 more degrees is pretty hot. But anything over 100 is pretty hot. So I don't want to be it either. So here's an example of a problem where you can change the equation around and then use it to your advantage. Give it a pause. Give it a try. Okay. Fever is generally considered to be a body temperature greater than 100 degrees Fahrenheit. Your friend has a temperature of 37 degrees Celsius. Does your friend have a fever? Well, we figured out that Fahrenheit equals 9/5 times C plus 32. So we're going to plug in the 37 degrees Celsius. So F equals, bring my calculator back out here. Alpha Y equals 9/5 times 37 is 66 and 3/5. 66 3/5 plus 32. So F equals, double check my math here, alpha Y equals 9/5 put the times in there just to be sure. Okay, good. Then we're going to add 32. So that's 98 3/5 degrees Fahrenheit, or 98.6 degrees Fahrenheit. So is that a fever? A fever is greater than 100, so do they have a fever? No. They actually have about average body temperature. You deposit $5,000 in an account that earns simple interest. Simple interest was I equals PRT. After 6 months, that's time, okay, and deposit is your principal, the account earns $162.50 in interest. What is the annual interest rate? Well, we want to know R. So that means I want to get rid of P and T. To get rid of P and T, next to each other means multiply, so to undo is divide. So R equals the interest, okay, that you earn over the principal times the time. So that for us is $5,000. Or sorry, your principal is the P thing. Is 162.5 divided by 5,000 for your principal times 6 months. Now let's go back and look at the equation. Here time is in years. When we look at our equation here, time is in months. 6 months, well, there's 12 months in a year, and we have 6 of those. Okay, actually that's upside down. There's 12 months in 1 year, and we have 6 of those, so that would be a half. So we're going to put a half in there, or 0.5 you could put in there if you wanted to. Okay, so now I'm going to bring my calculator back out, hopefully clear what I had earlier. 162.5 alpha y equals fraction decimal over 5,000, supposed to be 0, times 1/2. Enter, is 0.065. So R equals 0.065. 5's kind of bad there. Now, if we go back and look at our thing, okay, interest rate in decimal form. So this is our interest rate in decimal form right here, equals R. As a percentage, okay, as a percentage, we'd take that decimal place and we'd divide it by, or multiply it by 100, so we're going this way, so it'd be 6.5%. Okay, when you multiply, you go to the right, however many zeros you have. When you're doing factors of 10, when you divide, you go to the left. One more example. A truck driver averages 60 miles per hour while driving a freight to a customer. On the return trip, this is our rate. The driver averages 50 miles per hour due to construction. This is our rate. The total driving time is 6 hours. That's a T. How long does each trip take? Okay, these are the ones that I don't really like the way that they try to set them up. Okay, but he's driving the same distance. We have a rate times time and another rate times time. We know the time is 6.6 hours. What we don't know is the distance. The distance is the whole time is 6.6 hours. Okay, so we need distance equals rate times time. Time should be distance divided by rate equals time. So our distance divided by our rate is equal to our time. We know our time is 6.6 hours. We don't know is the distance. So we're going to have to set that up in a different way because our distance to there and back there is going to be the same. Distance equals rate times time. So if we set our distance up the same, because he starts here drives this way, starts here, drives that way, return trip, he's going to go the same amount. He's just doing it at a different rate for different amounts of time. So this one's distance, so distance of trip 1, where he's on his way, and distance of trip 2, where he's on his way, those are the same distance. D1 equals D2. So we can set R1 times T1 equal to R2 times T2. Okay. We told the total driving time equals 6.6 hours. We know T1 plus T2 equals 6.6. So we can find what one of those is and replace it, because we already know that this is 60 miles per hour. We can say that's times time 1. And we've got 50 miles per hour. And instead of time 2, we're going to put, we subtract from both sides, time 2 equals 6.6 minus time 1. So 6.6 minus t, needs to be better so you can tell what I'm writing, minus 6 point, oop, I already did that part, minus time 1. We're going to distribute. So 60 t equals, let's see what 50 times 6.6 is. 50 times 6.6, 330 minus 50t, add 50t. Okay, so we got 110 equals 330, 110t, divide by 110. Okay, so time 1 equals, drop the zeros, that'd be a factor of 3 hours. And we already said that T1 plus T2 is 6.6, so 3 plus time 2 equals 6.6 minus your 3. So time 2 equals 3.6 hours. How long does each trip take? Trip 1, 3 hours. Trip 2, 3.6 hours. I don't like the way they do these driving questions because it doesn't really, it's not super intuitive on the way you plug them together. But you got to think about what's the same. He went this way, a D. He went that way, a D. And it was the same distance. So we can tie the equations for distance together because the D's are equal. So we can set them equal here. That ties our RT equal to RT. Okay. Kind of a toughie, but I know you can handle it.